Okay, so this lesson is kind of divided in half. We're going to be talking about multiplying, and we're going to be talking about dividing radicals. Today I'm going to focus mostly on multiplying and then just introduce some of the division. We did do some last year, and then we're going to finish up that tomorrow after the quiz. Okay, so just a few reminders when we multiply radicals, okay? We're going to be multiplying coefficient by coefficient and radicand by radicand, okay? That's what we do when we multiply our exponents. So let's just do a bit of a warm-up, okay? We took a look at this, something similar to this before, but when we have the exact same number, that is the radicand, okay? Technically, when we multiply those two together, 2 times 2 would give us, okay, the square root of 4. But what is the square root of 4? 2. Exactly. So you'll notice that when you multiply something with the square root by itself, it, in a sense, it like undoes the square root. Okay, you're always going to end up with the radicand as a whole number. Okay, so if we do this, the square root of 3, we would multiply 3 times 3 is 9, but then we'd take the square root of it, so you're going to see that it's just 3. Okay, so what do you think? Square root of x. What's our answer going to be? X. Okay, so this is one of those examples. Do I need you to write the middle step? No, I just need you to understand that that's what's going on in the in-between in order to get to the answer. Now, let's say we change the index. Let's say we have cubed. Yeah?
Is x, that would be greater than or equal to 0?
So in the original question, yeah, there would be a restriction. Absolutely. Good catch. Okay. So for our final answer, we would have that as well. Okay. Now, if we change our index to a cubed, okay, it would take 3 of them in order to end up with a whole number. So, for example, if we multiplied those together, so 5 times 5 is 25, times 5 is 125. If we took the cubed root of 125, okay, that's where we would get 5. Okay, so we're just looking at patterns right now. So we notice that when we multiply a radicand by itself exactly, we end up, a radical, we end up with the radicand as a whole number. Okay, so what do you think is going to happen if we're taking the 4th root of something? How many would we need to have in order to get a whole number? Yeah, we would need 4. Exactly. Okay, so let's take a look at task number 1. Okay. We're going to step through a couple together, and then you guys are going to do some of those. If you're feeling like you're getting this, right, you're working ahead in the notes, and then you're just checking back when we get to that. So here, hey, I'm going to show you a couple things. So one of them is, okay, if you want to, you can regroup this a little bit just to visually organize it, because we're going to be multiplying the 2 coefficients together. So if you wanted to, you could kind of say, okay, I'm going to do the 6 times 2, and then I'm going to multiply the root 5, okay, times the root 3. Okay, you don't have to do this, but sometimes it's nice to kind of put the things together that you're going to be multiplying. So in this case, we have 12. So we multiply our coefficients, and then we multiply our 2 radicals. So we have root 15. Okay, our final step is we just have to double check. Can we simplify this? Can you simplify root 15? No. Okay. Any restrictions on this? No, why not? That's right, there's no x. Okay. So what happens? So let's take a look to B, and then we'll head up here. Okay. When we're doing this, there's 2 strategies that I want to introduce to you guys, okay? So one is simplify first, okay? The other would be to like multiply everything and then simplify at the end, okay? The reason I'm going to suggest simplifying first is because you end up with smaller numbers that you can do more easily, you know, with your mental math skills. So for example, when I'm simplifying this, I would take a look at 28 and I would say, wait a minute, I can simplify that because 4 times 7 is 28 and 4 is my perfect square. So if I were to take and split that up, okay, the 4 would come out and it would become a 2. So I have 2 root 7. Okay, and then I can't really simplify the second one. Okay, so it would stay there. Okay, we're good with our fractions. We just have to remember how to multiply fractions, right? So we would end up with 6 times 1/4. So we're going to put it like that for now. We'll simplify it at the end. And then we're doing 7 times 4. Okay, 7 times 4 will give us the square root of 98. Okay, can we simplify that? Yes. Okay, so that might mean for you, like, I don't know the factors of 98 off the top of my head. Okay, especially when I'm looking for the factor has to be a perfect square. So you might need to take your calculator, right, and just do a little bit of guess and check to see which is the highest perfect square that can go into 49. That can go into 98, which I just gave away, would be, okay, 49 times 2. All right, at this point, okay, it would be a good idea to simplify your fraction, okay, and you could show 49 times 2. Okay, so we end up with, sorry, let me put that backwards, 3/2, so I end up with, okay, so we end up with 21/2 root 2 as our answer. Okay, I want you to take a moment and I want you to solve this a second way. Instead of simplifying first, I want you to multiply the coefficients together, multiply the radicands together, okay, and then simplify. And then I want you to compare and see which one took less steps or which one would be more intuitive for you to do. Because sometimes we tend to do one way or the other. Yeah. Oh, that's times. Yeah, this is my times. Yeah. Sorry, it does look like a decimal. Okay, if we multiplied these together, I would end up with 3/4. And see, do you see what I'm saying? 28 times 14. Well, then I'd have to pull up my calculator because that one is a bit harder for me to do in my head. So 392. Okay, guys, what perfect square is hiding in 392? You see, like, it might take a little bit more effort if our numbers get too big. Okay, so that's why the strategy that I'm going to suggest is going to be simplify first, okay, and then multiply your things. But if you did it this way, it's not going to be incorrect. It just means that you're going to have to go through your perfect squares and go to a higher number. So for example, for this one, right, it's going to be, I didn't figure this one out ahead of time. 2 and 49. Let's see, 14. $96. Okay, so this would be 196 times 2. Okay, and the square root of 196 is 14. Okay, and then we still get the same answer. Okay, but I think multiplying them out and getting larger radicands, for me, it's a little bit harder. My brain would prefer to simplify and deal with smaller numbers. Okay, so sometimes I might ask you just here to try it both ways so that you have experience in solving it like that. Okay, so what I want you to do is, if you haven't already, I want you to give that one a try with the fractions. Okay, and then the one underneath where we do have a couple of variables. So I'll give you a couple minutes to write those out and then we'll go over them. All right, let's take a look at those. Okay, so for some of you, I walked around and I noticed some of you looked at this and went straight to the, okay, let's multiply those together. Okay, so you chose to deal with the large radicand, okay, which is fair, but then you have to be able to find out what the largest perfect square for that one is, okay? So in this case, it ended up being 225 times 2. The square root of 225 was 15. So 1/3 times 15, square root of 2. So you should have 5 root 2. Okay. When I solved it, I decided to simplify first. So here's your alternative. Okay, and I took the 1/3. I looked at the 45 and I thought, well, that's 9 times 5. I'd rather take the square root of 9. So that would give me 3 root 5, okay, times root 10. Okay, so this 1/3 of 3, okay, that just gives me 1. So I ended up with root 50. And that I know is 25 times 2. So when I take the square root of 25, I end up with 5 root 2. Okay. So sometimes you're going to see one way first, just follow it through. What I want you to do, you guys are at the level where I want you to observe first before you jump into the question. Okay, this one is an example of we could simplify it first. Okay, but if we look at this and we go, well, what's 27 times 3? Okay, that would be 81, which is a perfect square. I'd rather deal with the 81, okay, and then do our exponent laws instead of simplifying. Okay, so sometimes, like usually you simplify first, okay, but sometimes the question lends itself well to multiply it out first. So this one, if I multiplied them together, I'd get 81. And then we remember our exponent laws. When we multiply two bases, we add the exponents. So 5 plus 7 gives me 12. So I'm taking the square root of that combined. Okay, square root of 81 is 9. Okay, the square root of x to the power of 12. We take the 12, we divide by the index, which is 2. 12 divided by 2 is 6. Okay, and one of the questions that we had, okay, we were saying, are there restrictions on this one? Okay, you always have to look to the original question for the restrictions. Because the answer, right, we have an even index. The answer, there would be no restrictions. However, in the original question, let's put this one in purple, okay, we have odd exponents with an even index. So there would, okay, be restrictions on this question. Okay, and that would be why. All right, let's take a look at task number 2. Okay, so now we're just going to take multiplying radicals and we're just going to start to make it look like other things that we've done. Okay, we're going to take it into a binomial. So, okay, you guys know how to multiply into a binomial. Okay, so here's when I'm doing this question, this is the thought process that's going through my head. I'm going, okay, 2 times, like there's no coefficient, so I know the coefficient's 1. So I know I have 2. Okay, and I know that square root of 10 times the square root of 10 is going to give me just 10. If you want to write in the square root of 100, okay, and then take the square root of that, you can, but I'm hoping that you guys are at the point now where you recognize that 2, when you have the square root of 10 multiplied by itself, you just get 10, and then here we have the square root of 50. So radicand times radicand. And then we just have to simplify, so we have 20 plus 50 can be 25 times 2, so we have 5 root 2. Okay, and no restrictions on that because there aren't any variables under the radical sign. Okay, I'll do one more and then give you guys opportunity to do the try in your notes. Okay, so we're just doing 2 root 2 plus 2 times 2 gives me 2 root 2 plus 4. All right. I'm just going to circulate around while you guys are working on these 2 answers for that. Okay. So for this one, I get 3 root 75, subtract 3 times 15 gives me 45. Okay, I'm going to simplify. I know 75 is, this time I'm going to write out just a few more steps, 25 times 3, and 45 is my 9 times 5. Okay, so when I pull out the 25, that's 5, and I multiply it by 3, so that gives me 15 root 3, subtract 3 root 5. All right, and then our final one here. Okay, so we multiply our coefficients together. We multiply our radicands together. Minus 3, whoop, not a bracket, but a square root 2x. Okay, and then don't forget the restriction on that because we do have a variable underneath the square root sign. All right. Okay, this is probably as complicated as it's going to get. We're going to be doing binomial distribution. Sorry, what?
Is this one right?
Oh, yeah, you're good. Yeah. Sorry, I can bring it down a little if you want. There you go. Okay. So remember with binomial distribution, you're still going to be using your FOIL technique. First, outside, inside, last. Okay, if you want to draw the arrows just to visually help you do them, that's fine. So don't forget, when you do binomial distribution, your middle step will always have 4 terms. Okay, if you don't have 4 terms, then something went wrong. Okay, then you're going to collect your like terms at the end. Okay, so as we go through this, I'm going to have 3 times 5, which gives me my 15 root 7. Okay, I have, whoops, plus 20. Root 7 times root 7 is 7, so I'm just going to put that in brackets and take care of that in my next line. Okay. Oh, let me do it in order. Okay. 3 times that plus 6. Now I can do the 20 times 7. Okay, plus 6 root 7. Okay. Okay, we're going to collect like terms. You're going to notice that, at least for this one, we have some root 7s and then we have some constants. So 15 plus 6 gives me my 21 root 7. And then I have 6 plus 20 times 7. So 20 times 7 is 140 plus another 6, so plus 146. Okay. 23. Oh, I just didn't multiply correctly. Let's change that to 4 times 2 would be 8 and not 6. Okay, and that will just help me with my final answer. 15 plus 8 gives me 23. So we're gonna just go through A, B, and C, and then I'm gonna get you guys up at the boards to do the ones on the right. Okay, so some things that I want us to observe as we're going through those. Okay, this question we're going to FOIL. Okay, but I just want you to notice that these 2 binomials are exactly the same, except they have different signs. Okay, does anybody remember what that's called? Yeah, Felix. Difference of squares uses this. Okay, so we're going to hold on to that. Yeah, it's going to be a conjugate. Okay, so we did talk about it a little bit when we did factoring. Okay, and that the difference of squares, when you factor them, you end up with these things called conjugates. Conjugates comes back into this unit of radicals because that's going to be one of the techniques that we use tomorrow when we're learning more about dividing and rationalizing. Okay. An interesting thing about conjugates and the reason why we use it is because when we do FOIL, we multiply it out. So this gives us 1 minus 5 root 2 plus 5 root 2, and then subtract 25 times 2. Okay, so we'll notice that we have a plus 5 root 2 and a minus 5 root 2. So these 2 will drop out, and then we're left with these beautiful whole numbers. Okay, our radical sign completely disappears, right? It completely leaves. So we have 1 minus 50, so that gives us negative 49, okay, as our answer. And then for C, okay, I want to remind you of something. Like, let's take a look at 4 root 3, and let's say we square this. Okay, so last year you guys learned exponent laws, and this was called like power of a power, like when we square something. So normally what would happen is we would square, like this is the same as like writing it out 2 times, right? Okay, but I know you guys like to just like not have to write all the middle steps. So most of you would look at this and we would go, okay, I'm just going to square the first term, which is 16, square the second term. So root 3 times root 3 gives me 3. Okay, so this would give me 48. Okay, when we get to binomials, okay, can we just square the first term and square the second term? No. Okay, there are no exponent laws when we add or subtract. Exponent laws only happen when everything inside the bracket is being multiplied. Okay, as soon as you introduce a binomial, okay, you have to write it out in full. Okay, so you have to show me that a binomial means that there are 2 of them. I'm just going to make some room here. This is my example. Plus 3 root 5. Okay, so there's no getting around foiling. Okay, you still need to multiply all the terms, so we would end up with 16 times 3 plus 12 root 15, okay, plus 12 root 15 plus 9 times 5. Okay, so you'll notice for this that, okay, we end up with, okay, 24 root 15s, and then the 48 plus the 45 gives me 93. Okay. So when we square something that has a radical in it, we still end up with a radical as part of our answer. Okay. So why don't you guys stretch your legs a bit, head to the boards with your notes. Okay, and you're going to do these 3 questions on the right. You're going to do binomial expansion on that, try it with the conjugate, try it with the squared. I'm going to come around and take a look at your technique. Guys, quietly to make sure that, okay, what you've done is correct and accurate in your notes as well. Okay, so when we're doing FOIL, okay, we have x, all right, minus 3 root x plus root x minus 3. Okay, And you guys noticed that there wasn't a whole lot that you could collect, right? We can't combine them any more than what they already are, okay? You can't combine x's and root x's because they are different terms. Yeah. For this, no. Like usually, like again, if it was, usually we do the largest exponent first. So if it was a quadratic, we want to see the x squared, then the x, and then the constant. So very similarly, this is the largest exponent, it's 1. Because if we were to write this in exponential form, it would be half. So technically a square root of x would be a lower degree than a regular x. So this is like, this would be the order, but I'm not going to take marks off if it's in a slightly different order. Okay, that's why on this question here, okay, so sometimes, like usually we don't like having negatives in the front. So if anybody switched it and put their constant first and then the radical sign, that works too. Okay, so either or for this one. Okay, but by convention, yes, we usually do the higher index comes first. And then, of course, because there is a variable under the radical sign, you do have restrictions. Okay, and then this one, we saw this one was a conjugate, so we're going to end up with, okay, x squared plus okay, there's no restrictions on this one because there's no variable underneath the radical sign. Okay, so I think you guys are good with that. Okay, so make sure you're updating these, right? Okay. Okay, so this one, 4x minus 4 root of x plus 1, x has got to be greater or equal to 0. Okay, and our final one here. Okay, so have you guys noticed that sometimes the questions only vary very slightly? Okay, because I'm hoping that you have some observations. So these two questions are almost identical. They're a binomial and they're squared. However, one has a negative, one has a positive. Okay, so what could you tell me about the answer that I would expect to see on this side? Okay, would it be similar, the same? Cameron?
It would be the same except for the middle term would be positive.
Yeah. Okay, so have you guys noticed that? Like when there's a negative in your binomial, there better be a negative in your answer. Okay, and then when there's a positive in your binomial, once you do this, okay, and I have plus 2x plus 2x plus 1. Okay, then that also shows up in my answer as well. Okay, so that's just another way that you guys can check to make sure that you're on the right track with your answers. That you can look for clues, okay, and knowing the patterns that you see, okay, that those will show up. Okay. So in a few minutes, we're going to circle back to page 289, but I just wanted to kind of confirm and to talk about conjugate, because that way tomorrow, right, after the quiz, that we can jump into our lesson having already gone over some definitions. Okay, so some of you remember the word conjugate when we were doing difference of squares. Okay, the thing that you need to remember, okay, so two binomials, okay, that have, that they just reverse the sign in the middle. Okay, so for example, here's a binomial and they'd say, what is its conjugate? You would write the exact same numbers except you would reverse the sign. So if one's a negative, its conjugate is a positive. Okay, if I gave you 3 plus root 5, and I said, what's its conjugate? You would tell me. What? Yeah, exactly. Not a trick question. Okay, it would be 3 minus root 5. Okay. The other thing that I want you to recognize is when you multiply two conjugates, okay, the same thing happens and this is why we choose conjugates. Okay, so when we distribute this, so 16, okay, we have plus 4 root 6, we have minus 4 root 6, and then we have times 6. Okay, so this gives us, okay, what you'll notice, every single time we use a conjugate, those middle two terms are going to drop out. Okay, and then we're left with, okay, this amazing whole number. So we have, whoops, let's try 22. Let's try making sure my signs are correct. Okay, negative times a positive. Okay, that will give me 10. There we go. That looks good. Okay, so the reason why we introduce conjugates, just like when we did our last unit, right, when we were doing quadratics, and we learned the technique of completing the square so that we could go from standard form to vertex form, we're doing the same sort of thing. We're introducing a technique, right, so that you can do what's called rationalizing the denominator. We touched on it a bit in grade 10 in our trigonometry unit. Okay, but it might have been a while since you guys did the grade 10, so we'll review that one. Okay, so let's just take a couple more walks down memory lane. Okay, and let's take a look here at task number 1. Okay, I'll come back to the definition stuff at the top. We're on this page now. Okay, so just remember, just like multiplication, when you multiplied your two radicans and you could put them under one radical sign, the same is true for division. Okay, when you're dividing radicals, you can come if they have the same index. Okay, so maybe make a note for yourself. Okay, if they have the same index, you can combine them. Okay, so these are both a square root, and so I can put them both under one square root sign. Okay, and then I can do the division. So 20 divided by 5 just gives me 4. So the square root of 4 gives me 2. Okay, so try the next one. Okay, square root of 90 divided by the square root of 15. Okay, hopefully you got the 90 divided by 15. Okay, which gives us square root of 6. Okay. Yeah.
So you have to put it under first number, or could you just like rationalize?
You can, okay, but this is easier. Okay, and we're going to get into rationalizing in a sec. I just want to remind you of the basic rules that if you can divide it, let's divide it first before we jump into rationalizing. Sometimes we know a technique and that's our first go-to, when if we observe the question first, we can say, hey, wait a minute, there's a slightly easier way to approach it. Okay, so this one, same sort of thing. Don't forget your exponent laws. Okay, same index. Okay, guys. Okay, same index, so we're going to combine them under one radical sign. So we have 45 x to the power 3 divided by 5 x to the power 7. So the 45 divided by 5, I think we're good with that. We know it's 9. Okay, don't forget your exponent laws. When you have the same base and you're dividing, what do you do with your exponents? Subtract. Exactly. So we have x. Hey guys, what do we do now? We have a negative number. We have x to the negative 4. Okay, Will? Okay, awesome. Okay, the 9 as well, or just the x?
Just the X.
Okay, you are correct. What? Let's get that as a 4. Okay, so when you have a negative exponent, we always express our answers with positive exponents. So that means we'd have to take the reciprocal of the x, which means that the x goes on the bottom. The exponent becomes positive because we've taken care of it. Okay, I would expect that you guys would continue and actually take the square root of your answer. So the square root of 9 gives me 3, and the square root of x to the power 4, 4 divided by 2, which is my index, gives me 2. Okay. And, okay, I would go to the, oh, guys, here's an interesting thing. I just wrote, because I'm used to writing it, x has to be greater than or equal to 0. However, could x be 0? Why could x not be 0? Yeah. Yeah. Okay, you can't divide by 0. So don't write things down just because you always write things down. Don't forget to pause, take a look, observe. Okay, so this one is just x has to be greater than or equal to 0, or greater than 0. Okay. Okay, not greater than or equal to 0. Okay, because you cannot divide by 0. Okay. So this will be our last topic for today, and then I'll give you guys some time to do your practice questions. So this one, okay, Kessler, now we're going to do the technique where we're going to rationalize our denominator. So the whole idea of rationalizing just means that mathematicians at some point in time decided that, just like how we don't want negative exponents, they also said we don't want a radical, right? We don't want a root sign in the denominator of our expression. So we just need to take care of that. Okay, and they call the process rationalizing. Okay, do we have a problem with the 5 in the denominator? No, just the root 2. Okay, so the process, okay, this is a bit of a review because you guys learned this in grade 10. So the process is you multiply it, okay, by its conjugate. Well, what's the conjugate of root 2? Okay, it's just going to be itself. Okay, the idea of a conjugate where we change the sign, that's when we have a binomial. Okay, if we multiply it by itself, hey guys, what was the rule when we dealt with fractions? Whatever you do to the bottom, you do to the top, exactly. Okay, so because I'm rationalizing the denominator, I have to multiply top and bottom by whatever radicand is on the bottom. Okay, and then from there, I'm doing 8 root 30. And on the bottom, I'm doing 5 times 2 because I'm going root 2 times root 2 gives me 2, and it still gets multiplied by the 5. Okay, then we have to simplify. So I'm going to actually simplify at this stage. Okay, I'm going to say, I'm going to divide the 8 by 2, and it goes in 4 times. So my final answer is going to be 4 over 5, okay, root 30. Now you guys know that, okay, let me just rewrite this a little neater. So 4 root 30 all over 5. Okay, don't forget the thing with fractions and multiplying. This is exactly the same as pulling the fraction out in front of the root 30 like this. Okay, these two are equivalent. So sometimes in your textbook, you might see an answer where it's a fraction form in front of the radical instead of everything over the radical. These two are exactly the same. Okay, they're equivalent. So don't forget your equivalent forms. Okay, if you're feeling awesome about this, go ahead and rationalize root 10 over root 3. Okay, so hopefully you did root 3 times root 3, so you ended up with 30, okay, over root 30 over 3. Okay. Now again, yeah, you have a question? Sure. Okay. If you can simplify, I'm going to suggest you simplify first to keep your numbers small. I don't want to be multiplying top and bottom by root 75. Okay. How about if we if we simplify root 75 and recognize that that's 25 times 3, take the square root of 25. Okay, so we have 25, 5 root 3. Okay, I can even say 25 divided by 5, right? This gives me 5. So now I have 5 root 3. Rationalizing that is a lot nicer. Okay, so I'm going to multiply it by root 3 over root 3, which gives me 5 root 3 all over 3. Okay, this final one, don't forget you can use the 2 kind of techniques that we used. Okay, we're still going to rationalize it, but don't forget that we can combine some of the numbers just to get our numbers smaller. Okay, so for this one, when I look at it, okay, I'm like, oh, there's really nothing that jumps out that I could, like 70, that I can break 70 apart. But if I did this, 5 over 7, and I combined 21 over 70 like this, okay, I could take a 7 out of both of those, right? I could do, right, my fraction, I could reduce it to 3/10. Okay. Now to rationalize this, I'd have to then separate them back out again, right? So I'd have to have the root 3 and put the root 10 back again. Okay, so that again, that you can really see that there's a square root of 10 on the denominator, and that's what I have issues with. Okay, you don't have to multiply it by the whole denominator, only the radical part. Okay, because we don't have any issues with the 7, it's just with the root 10. So I'd multiply top and bottom by root 10. Okay, and then that would get me 5 root 30 over 7 times 10. Okay, we can simplify. 5 goes into 10 2 times, so I have root 30 over 14. Okay. All right, why don't you go ahead and grab your textbooks from the side, okay, and let's start with your homework questions on page 289. And then before the end of the class, I'll hand out your practice quizzes for tonight and just review that before we're dismissed. Okay, so go ahead and get your